Okay, so this is the problem that we got as the take-home problem for the third exam. So the problem states that if a 2 kilogram mass has a initial velocity of this, and a 3 kilogram mass has initial velocity of this, after the collision, the 2 kilogram mass has a speed of this, and the 3 kilogram mass travels at an angle of this from the positive x-axis. So what we had to find was the speed of the 3 kilogram mass and the angle that the 2 kilogram mass traveled after the collision. So the first thing we do is state what the system is. So my system is basically just the two masses colliding with each other. The question also states that the masses collide perfectly elastically. So what that tells me is that both the kinetic energy of the system and the momentum of the system is conserved. So this is how I did my problem. I took the velocity vectors of both of them, and using Pythagoras theorem, I found the magnitude of the velocity of the 2 kilogram mass and the 3 kilogram mass. So what I did was 5 squared plus 7 squared, and taking the square root of that, I found that the initial velocity of the 2 kilogram mass was square root of 74 meters per second, and for the 3 kilogram mass it was the square root of 10 meters per second. Then using that the kinetic energy is conserved, so meaning the kinetic energy initial of the system is going to equal the kinetic energy final of the system. So using this equation, what I did was 1/2 times mass of the first one times the velocity initial squared plus mass of the second one times 1/2 times velocity initial of the second one squared is equal to 1/2 mass of the first one times velocity final squared, and 1/2 plus 1/2 mass times velocity final of the 3 kilogram mass squared. After plugging all the numbers in, I found V, which came out to be 26, the square root of 26 meters per second. So that's the velocity I got for the 3 kilogram mass. Then for the to find the direction of the 2 kilogram mass, I used the idea that the momentum initial is going to equal the momentum final. So what I did was momentum of the mass of the first one times the velocity of the first one in the x direction times mass of the second one times velocity of the second one in the x direction is equal to mass of the first one times velocity times cosine theta, which will give me the velocity in the x direction, and mass of the second one times velocity times cosine theta, which will give me the velocity in the x direction. So I did 2 times 5, which I got from there. So 2 times 5 plus 3 times 1 is this. This is the square root of 50 was stated in the question, and the angle that the 3 kilogram mass traveled in was also given. So setting up the equation like this, I found theta, which turned out to be 102.52. So the 2 kilogram mass travels at the speed of the square root of 50 meters per second and at an angle of 102.52 degrees from the positive x-axis.